Hi, welcome to lesson 4, unit 1. You just created your own number systems using circles and squares. So, what can we communicate using only two symbols? And is there a limit if we only have these two symbols? Think about that for a minute and press pause. When you're done thinking, you can unpause. So today we're going to explore how binary numbers work from a really conceptual place. So with only one place value, we have only two possible patterns, a circle or a square. I started with a circle, but I could have easily started with a square instead. So I have one place value. In that place, I could either have a circle or a square. If I have two place values, with two place values, we can make two sets of the previous pattern. Then insert circles. Those are our two sets from the previous pattern. Then I can insert circles in front of each of these patterns. And I end up with 4 possible patterns. What about for 3 place values? For 3 place values, we can make 2 copies of the 2 place value patterns, right? So there are 2 copies of the 2 place value. Then I can make, right? Then I can add circles in front of all of these copies and squares in front of these, creating 8 possible patterns. 1 pattern, 2 patterns, 3 patterns, 4 patterns, 5, 6, 7, 8 possible patterns. We can map these patterns to a numbered list and note that computer scientists like counting at 0. So when I was counting 1 through 8, I was counting the number of patterns, right? 8 possible patterns. But we can map this to just a numbered list. And computer scientists like to start counting at 0 for their numbered list. So instead of 2 shapes, what if we had 10 shapes? So let's just take a moment here. Instead of 2 shapes, we have 2 shapes here, circles and squares. But what if we had 10 shapes? Does that sound familiar to any of you? Do any of you know a number system that has 10 shapes? So let's think about this. 1 place value, and we have 10 one-shaped patterns. So let's think about an example. We could use more geometric shapes, or we could use letters, but the shapes we are used to are the numbers 0 through 9. And think about these. 0 through 9, these are just shapes. If we have 2 places with 10 different shapes, we can have 100 two-shape patterns, can't we? What are those 100 two-shape patterns? So you might be sitting here and saying, yeah, Ms. Bird, I know how to count. But an idea of how number systems work, this is very fundamental to realize that number systems are simply just shapes, whether or not we're talking about, like for us, we're most familiar with a 10-shaped number system. So think about this. What comes next? If you have 10 shapes, what comes after? If you've filled in all your shapes, if you've maxed out your first place value or your second place value, what happens here? My guess is you all know. You get 100. So of course, I'm sure you were on your other side saying like 100. When we run up to the last shape 9, we roll back to 0 and we add 1 to the place value to the left. This is the place value that this is the place value we have all used in our lives. Like we've all done this before. So where is this all heading? Right? You're like, okay, yep. I get this. Where is it heading? So it's heading to binary. Binary is a number system with only 2 shapes. Not circles and squares. But rather zeros and ones. So let's make an organized list counting in binary. So instead of shapes, we're going to use ones and zeros in this example. And in this example, each pattern maps to a decimal number from 0 to 7. Take a moment and explore and thinking about the slides that we've just looked at. And looking at our decimal system, 0 through 7. Using our example of squares and circles, and then this binary simply using 2 shapes instead of circles and squares. And for today, that's where we're going to stop.